Okay, so let's continue to what we have been doing. So by the way, your friend was asking me, oh, hocam, you write current account deficit like this. So it's because it's a negative number, I called it current account, like deficit, but usually you can actually call it the current account balance. If it's positive, you call it current account surplus. If it's negative, you call it current account deficit. And for Turkey, because it's negative, we know, that's why I wrote it as, this number is going to be a negative number. Okay, that's why I wrote down current account deficit. Okay, now what we will do is that, as I said, that elasticity is very important, even though it doesn't look very important when you write these down. But, as we figured out that apparently it has an important meaning, in terms of many policy issues and such. Now, and also, as I told you, that Toyota or, let's say Toyota, Starbucks, they might ask Ipsos, or any sort of, or you guys, if you work in these kind of stuff, they would ask actually, for instance, how would my total revenue change? Okay. For instance, when I change the price of caramel macchiatos. So Starbucks might wonder, okay, I'm planning to change the caramel macchiatos. What do you think is the amount Starbucks receives? Suppose it's the demand for caramel macchiatos is this X star. How much money do you think Starbucks is going to receive? In total? If suppose your demand, the total demand is X star, should be PX times, right? So as I said, it's not a tricky question, right? So PX times X star, right? So Starbucks would like to know, I want to change, this is going to be Starbucks total revenue, not profit. We'll see, right? Because Starbucks has some cost. So to get profit, we need to get the cost out of this. But this is actually the money that they make, right? So it's total revenue. So it's basically, so then Starbucks might ask this. When price of caramel macchiato changes, how would the money that I'm going to get is going to change, right? That's a very valid question. So Toyota is interested in that. Starbucks is interested in that. Arçelik is interested in that, right? So then let's see what this is. So let's try to see when I take the derivative with respect to PX, first I can write X star, right? And then I have to take the derivative with respect to, and I'm going to keep PX, and I'm going to take the derivative with respect to X star, right? Because it's the multiplication, right? It's the product. I'm taking the derivative of this product. And then I have this. When I take this into X star parentheses, it's going to be 1 plus PX divided by X star, dal X star over dal PX, okay? Do things look familiar here? What is this guy? Right, so this is nothing but the elasticity, right? X, PX. So you see that it's very important. So if Starbucks knows the elasticity of demand for caramel macchiatos, right? Then they can figure out whether this is going to change, how it would change its total revenue, right? So so that you would have nice notes, let me write this. So as a title, how does a change in price, okay, affect total spending on that good? Okay, so this is actually the question. So we want to know what's going to happen to caramel macchiatos, okay? Now, it's going to be, so this is basically the case, so total spending on that good. So what about this numbers? So can you tell me what's going to happen here? Can you say, is it going to increase, decrease? What's going to happen? It Depends, right? It depends on this elasticity number. So suppose if demand is elastic, so if xpx is less than -1, right? So if we have an elastic demand, what's going to happen? It means that it's like a number -2, -3, right? And then this is going to be negative, meaning that when px increases, the amount that Starbucks is going to receive will decrease, right? So if this is elastic, then del px times x star divided by del px is going to be negative. It makes sense, right? Because I'm going to decrease my price by, or increase my price by 1%. I know that the quantity is going to respond more than 1%, right? So overall, it's going to decrease. So you see, and then suppose it's my elasticity is unit elastic. What's going to happen? So del px x star del px, this is going to be what?
No change.
0, right? So if this is -1, put here -1, this is 0. So when price changes, so apparently quantity demanded of that good is not, it will change, but by exactly 1%. So 1% increase in price, 1% increase in quantity, overall, right? The total spending on caramel macchiatos will not change, okay? Or Starbucks' total revenue from caramel macchiatos is not going to change. And you see that if this is greater than -1, we say it's inelastic. So suppose it's -1 over 2, minus 0.5. Then what is going to, this derivative would be what? Greater than 0. Then it would be positive because Starbucks increases the price, but the quantity is not going to decrease that much. Apparently people like caramel macchiatos a lot, so that they can make more money now, right? So then this is going to be positive, okay? So you see it's, you can get many you can get many interesting applications with elasticity, okay? Even though students mostly, they don't like, but you can actually say a lot using elasticities, okay? Now, but remember we had two demand curves. One was the uncompensated Marshallian demand curve, and the other one is the compensated one, right? We wrote down elasticities for that guy. Now let's write down elasticities for this guy, okay? Now I'm going to have, so I'm going to call this compensated demand elasticities, okay? So let's call this compensated demand elasticities, okay? So let's do it like this. So then we're going to call this compensated, so I'm going to write down the additions with blue, compensated own price elasticity of demand, okay? And then I'm going to call this guy XC, compensated own price elasticity of demand. And then this is going to be XC, this is going to be XC, all these guys, okay? And then this, can I keep this? No, right? Because now the compensated demand, it should be what? Utility, right? There should be U. And this is XC, okay? And I'm erasing all these guys. Okay, so what can I say about this elasticity? The sign of this elasticity, compensated own price elasticity. What is this? If I look at here, so this is positive, right? What is this? What did we say? We said it's always negative, right? Because this was giving what? Substitution effect, right? So we said it's always negative. So compensated own price elasticity of demand is negative always, right? Because there's no income effect. Remember here for the compensated demand curve, right? We said we get rid of the income effect. So the other one, obviously there won't be income elasticity of demand because we get rid of any changes in income and such. So then I'm going to call this cross price elasticity of compensated. So let's call this compensated cross price elasticity of demand, okay? So this is going to be XC, but I'm going to put here PY. So XC, PY, so this is going to be XC, XC, so this is PY, PY, XC, so this is PY, okay, so this is XC, again I get rid of this guy, this is PY, XC, this is PY, okay, so this is basically it. So this is actually called the cross-price elasticity, compensated cross-price elasticity of demand, okay? Now, so you see that because we don't have income elasticity, because we don't know that there's no income effect going on here, right, for this guy. Now, I'm going to link the Marshallian price elasticity to the compensated price elasticity of demand. So how shall I do that? Do you have any ideas? I want to link these two guys together. Okay, I want to, so let's do this. Linking, let's call it linking elasticity X PX to elasticity XC PX, okay? So if I want to link this guy, basically del X star del PX over X star and del XC over del PX PX over XC. I want to link these guys together. So what should I use? How can I do this? Yes. Right, so remember, I don't know the elasticity version, but I know the relationship between this guy and this guy, right? Through Slutsky equation, right? So let's do this. So remember, so recall Slutsky, okay? So equation. So let's write this. It was this. Remember, del X star del PX was equal to del XC del PX minus del X star del I times X star, okay? Now, what I'm going to do is that I'm going to multiply both sides by PX over X star, and here PX over X star as well, okay? Now, I'm going to, so this way, it's going to be elasticity of, right, X star PX, or I can call it XPX, whatever you want to call, okay, on this side. But what about this? So basically, remember when we get the Slutsky equation, it was actually at a point where XC is equal to X star. So if you want, I can actually get rid of this guy, but I can actually write this here, PX over X, right? And then I also have PX over X star, okay? Now, I have, so this guy is going to be, so remember we said that when we write down Slutsky, X star and XC were, you know, like for small changes in price, they were equal to each other. So basically here I put XCPX, right? But I have these guys as well. So what's going on here? Let's actually do this. Let me put here, I need an I, right? Let me put here I times I. I multiply by I and divide by I, okay? So this guy here is what? What is that? It's the income elasticity. This one? No, right? It's not. Which one is the income elasticity? I should be here, X star should be here. It is, we will have this, don't worry, but not from these guys, but you would get it from these guys, right? So del X star, del I divided by X star, okay? So this guy is X star I. Income elasticity of demand, of the Marshallian demand. And what else I have? I have this guy here. So this part. What is this? This is X star Px divided by I. This is the money that I spent on X. This is my total income. So let's call this S of X. So basically it's the budget share of X, okay? So X of share of good X in the budget, right? Sort of, right? So basically budget, let's call this budget share of X and let's put SX, okay? So you see using Slutsky, we actually get the relationship between the elasticity of the uncompensated demand curve and the elasticity of the compensated demand curve. When do you think these guys are equal to each other? Huh? So right, so if this guy is equal to this guy, then you should think of, okay, these guys should disappear, right? So they are very close to, so X star Px and XCPX are close, right? There could be two things, as you said that. The first one, either the income elasticity is very small, right? Suppose this is 0, then they will be very close to each other, right? If income elasticity is close to 0, meaning that there is no income effect going on, so the demand, uncompensated demand curve is very similar to the compensated demand curve, right? So the first one is that this is small, very small, okay? The income elasticity, or what else? Right? Or the budget share should be small. So the good, so you can actually think of it like this. Even if, suppose the income elasticity is really big, but the share of that good in the budget is tiny, then when you change the price of that good, the guy is not going to feel that richer, right? Because for instance, think of salt, right? How much it occupies in your budget, right? So the change in price of salt or whatever, like it's, even though, let's say, but of course then you might tell me that, oh, hocam, the income elasticity of salt is also very small, right? But think of something where it constitutes a small portion of your budget, but the income elasticity is pretty high, okay? But even in that case, these guys would be very close to each other, okay? So either this, or we actually have the budget share is small. Or we can think of it like this. Suppose we have a good which has a large budget share, then if the income elasticity is small, then these guys would be close to each other, okay? So even if the budget share is large, if this guy is small, then it's okay, okay? So you see that you can make all sorts of these kind of analysis under which conditions these two elasticities are very close to each other. So it should be for goods, either the share of the budget is really tiny, or you should have some goods where the income effect is not actually that important, okay? Then the compensated demand curve and the uncompensated demand curve are very similar to each other, okay? So basically this, with this, this kind of finishes up our consumption theory, okay? This finishes up the theory of consumers. Now, what we will do is that, remember, I promised you, I said that once we understood this consumer, what's going on in the consumer theory, it's going to be very easy for us to understand firm theory, okay? What's happening on the firm's side? We're going to have very similar concepts. We're going to have you'll see that even the curves that we have would be very much the same, okay? But let me ask you this. So we are starting now, so you can have a big heading, to the production, okay? Or you can actually call it firm theory, okay? But let me ask you this. What does a firm do? So what do they produce, right? But what do they do? How do they produce? Right, so they take, basically what they do is they take inputs, right? And they convert them to outputs, right? So basically that's what they do. Okay. Now, how do they do this? We don't know. The people who are doing this is not us, actually, are basically how they do it is mostly the job of our engineer friends, okay? So how they do it is basically, they say that they take these inputs and they give some output, right? So there is actually a function like f, and then as you said that hocam, they take capital, right? So they basically take capital and let's say labor, right? They might use raw materials and then a bunch of other inputs, right? So let's say, and they convert this to output. This, how they do this, we represent this via this function f, and we call this production function. Okay? As economists, that's not our job. You know, like the best production function, we trust our engineer friends that they're going to give us the best way to get the most out of capital, labor, these, like raw materials and such, okay? So let's say your friends work at Arçelik or Vestel or Toyota, okay? And they try to figure out the production, the best production process, so that when you use this much machinery, this much workers, and then this much raw materials, you get this much output, okay? So as economists, this F, we take this as given, okay? That's not our job. We might try to give some incentives to our engineer friends, to firms, to R&D, right, research and development, to change this F. We might them to be able to produce in a much, you'll see, more productive or efficient ways. But as we said that, this is not, in firm theory, we're not going to consider how firm is going to decide on F. No, okay? So that's, as I said, that we trust our good engineer friends, like that they're going to give us the best way, okay, to convert these inputs into outputs, okay? Now, this is called production function, and these are inputs. So this is capital, but there is always this misunderstanding. Whenever we say capital, people always think of sermaye and immediately they think of money, okay, what we call financial capital. So, but here, this is capital, this is actually the real capital, sort of what we call the physical capital, okay? So literally the machinery, okay? So for instance, the trucks that you have, the warehouses you have, okay? So this is what we mean by capital. The capital that you keep hearing in the news is used to make investments. This financial capital, right? You use it to make investments, and therefore you would actually get these physical capital, right? But the one that is helpful in the production process is not money itself, right? You have to get some computers, some stuff, okay? So let's say computers, etc., okay? So now this is physical capital, this is labor, this is iş gücü, fiziki sermaye, okay, and you can actually think of raw materials. Okay, you might have, it depends on the firm, right? Whatever they produce. Sometimes these raw materials are very important. Or in a let's say in a software engineering firm, what would you have? Would you have any raw materials? No, what is the rawest thing there is probably the human beings, right? So it's actually, right, so it depends what they produce, right? Now, so you see, and you might have a bunch of other inputs. You might have entrepreneurial input. You can also think of it like that. You might have also what you call, sometimes they put labor, but they differentiate between the human capital, right, and labor, right? So beşeri sermaye denilen bir şey de var biliyorsunuz. So the human capital, right? So it could be like many inputs. But this is what firms do. And the process, how they convert these guys to these guys, is represented via some function f, right? Like some utility function, you can think of it, okay? So then, fine. As I said that this f is the best way, we trust our engineer friends, it's the best way to produce this output, okay? So that's what we assume. And now, as we did in the consumer theory, mostly we're going to assume we would have two inputs. We're going to have capital, as I said, physical capital, the real, you know, like what is used in the production process. You cannot use money, right? If you put money is not going to give you anything. You have to buy something with money, and then that's going to produce, okay? So capital and labor. So basically, we're going to assume that this production function is going to give you, with this amount of capital and with this amount of labor, what is the maximum amount of output you'll be able to produce, okay? So in that sense, this is your F, okay, production function. So we trust our engineer friends. So as I said that, this is just like our, you can think of it as our utility function, okay? So remember again, we said that for rakı, if you want to change some stuff, you need to change people's behavior, right? So that's what we say, you need to change the fundamentals. Here it's very similar. If you want to change some stuff, it might be the case that you might want to improve on this F, right? So that's what R&D does, right? So they try to come up with the best way of producing, you know, like best way of producing a certain good, let's say washing machines or whatever, okay? Now, remember with utility, we had the concept called marginal utility, right? So what was marginal utility? It was basically marginal utility. It was the partial derivative of the utility function with respect to x, right? So we called it u of x, right? Just as we had marginal utility here, we're going to have the derivative of this f with respect to capital, the derivative of this f with respect to labor. And we're going to call this marginal product, marginal productivity, okay? So this is going to be called marginal product of capital, and this is going to be called marginal product of labor, okay, or marginal productivity of labor, okay? So what is this? So this is, you can call it f of k, f of l, right? So it's very similar, the way we interpret it. It means, remember, marginal utility was this. When I consume one more unit of x, how much will this contribute, right, to my total utility? Here, it's very similar. So let's actually, maybe I can put it like this. Marginal product of capital. So you can also write it del Q over del K. Okay, del Q over del L. Okay. So it means, what does that mean? It means that when I use one more labor, suppose I hire one more labor, how much this guy is going to contribute to my total output. Suppose Arçelik says that, okay, I'm going to hire one more labor, and how much additional output this labor, how much additional washing machines this labor is going to bring me, okay? So it might not be, of course, when you think of the washing machines on a bigger scale, but you might think of it as the coffee machine, right? What's it called? Telve, right? Arçelik's one. Do you know? Turkish coffee machine. I think it's called telve. So it's like, you know, like I hired one more worker. How would this worker contribute to my total production? Okay? So you see that this is marginal product of labor, very similar. So let's be proper. F of L, KL. So del K. So this is F of K. So del F KL del L F of L. Okay? So marginal, what else we said about actually marginal utility? So we said that marginal utility U of X is, what did we say? U of X is, was it positive, negative? So U of X being positive corresponded to what? Ne dedik? More is better, right? So remember that it corresponds to the case where more is better, right? So it's actually, so do you expect this F of X and F of L to be positive as well? Right? Probably they are positive, right? As you keep increasing the amount of capital and labor, you should be able to produce more. But again, you have to think of it with some sort of, like concern. So, but then what did we say? What about this? What did we say? Yes.
Bir tanesini arttırıyoruz ama diğeri sabit. Mesela onu arttırdığımızda daha çok üretemiyor olabiliriz.
Exactly. So he's right. He's just, don't forget that even in this case, or in this case, these guys are partial derivatives, right? So what you do is, for instance, let's not think of Arçelik, but let's think of Mozart Cafe. Okay, you know Mozart, right? Downstairs. So let's think of Mozart Cafe. Mozart Cafe has a limited space, right? Let's call it capital. It's chairs, tables, ovens, whatever. And then I keep adding labor to Mozart Cafe, right? At some point, what would you expect? This might go to negative, right? Because the guys might get each other's way or whatever, right? So the issue is that they might start producing in, it might, if you add another guy, it might decrease your consumption, right? It is possible. That's why I didn't say that this is always positive, right? But you are right. But what did we say about this guy, the marginal utility? Then we said this is positive or negative. And how did we call this? We call that this is diminishing marginal utility, right? Remember we gave the example. If I keep giving you chocolate, okay, you eat, you would be happy, right? The first unit is going to bring you utility. The second one might even bring you more. The third one bring you, let's say, more. But eventually, the additional utility, even though every time you might enjoy it, the additional utility it's going to bring you, eventually it's going to fall, right? So that's what we said, diminishing marginal utility. So what about this? What do you think about these guys? Do you think we also have similar stuff here as well, right? As your friend was saying, that suppose Mozart Cafe, I keep increasing because I keep labor the same. I keep capital the same, so let's actually do this, right? So it's F of K L L, let's put it like this. I kept increasing amount of labor, but don't forget that I keep amount of capital fixed here, right? So what's going to happen when I add one more worker to Mozart Cafe? He might contribute to my output, right? A lot. Let's say I hired the second worker. Now there might be division of labor between them. The second worker might contribute even more than the first one. But as I keep on doing this, when I come to the 100th worker at Mozart Cafe, right, the contribution of that guy to my total output is going to definitely fall. It might be even negative, right? So it's actually, we also have this diminishing marginal productivity idea, okay? So here we also have F of KK, and so is negative, F of LL is negative, okay? So diminishing marginal productivity of capital and labor. Okay? So eventually this is going to, basically we say that eventually it's going to fall. Yes?
Likewise, can we also show the disutility of consumption? Like even like consuming a lot of goods, a time will come when the utility converts into disutility.
Yes, so that's what we are saying, right? So you keep adding workers to Mozart Cafe. At some point, it would contribute to this production.
Talking about in perspective of the consumer theory.
Yes.
Like, can we also show that in the consumer theory as well? This utility.
Yes, of course. So if remember, it's if this is not always for every x, after very large x's, if this becomes negative, right, the additional, how it's going to contribute to your total utility is not positive, but in negative, so it's going to be this utility, right?
So are we only following the positive part, or can we also show, or can we, or are we like, I'm like confused, like, are we all only emphasizing on the positive part, like the utility of work, or utility of consumption, and not the disutility of consumption, right?
So if there is more is better, there is no disutility of consumption. But if there is no more is better, you're absolutely right. There could be disutility of consumption. Okay, that's what I'm saying. So basically, so let's see, let me say this. So diminishing marginal product of capital and labor. So we have these phenomena, right? So you can actually call it like this. So f of k l del k, okay, and this is del square f of k l del l squared, okay? So just as we had the diminishing marginal utility, we have similar concept. But here's the thing, you know that who figured this out? Who first introduced actually the fact that marginal product of labors, so this f of LL is negative, and this is going to cause the end of the world. So it's actually, no, it was even, before, like, have you heard anyone called Malthus, Thomas Malthus, right? So that's what he figured out. He said that, people are actually growing exponentially, but the land, back then, only production was agricultural production, right? So they thought that, he thought that, land is limited, but, people are growing exponentially. So when you keep adding, like these people to this fixed input, which is land, you have eventually the productivity of labor would fall, and this is not going to be enough to feed the entire population, okay? But he missed something. What was it? Industrial Revolution, or, like remember, this might fall, yes, but here you keep, when you look at, you keep capital fixed. If this guy is growing as well, then things might not be that bad, okay? And that's why he's actually, because of this, you know what dismal means? Sometimes economists are called, economics is called dismal science. Have you heard anything like this? Sometimes economics is called the dismal science. Dismal means pessimistic, okay? So this is actually due to him, because of his pessimistic views, economics was called actually the pessimist, the dismal science, and sometimes people call themselves as dismal scientists, okay? But Malthus he didn't take into account the fact that, okay, people are smart enough that they can actually change this fixed capital so that this does not have to be, right? You don't have to apply. So you can have another Mozart cafe, right? So then half of the people can go and work at that new Mozart cafe, and which is not going, so things are not that bad, okay?